Thank you everyone for joining. I know this is a long day and you had more other presentations. So a little bit about me. I'm Andrii, I'm a principal software engineer and delivery hero. And if you would have any questions or want to contact me, you can find me on all of these social networks. This time, Session Ice provides us some QR code. So if you have some feedback, you can use this QR code to give me feedback. I don't know if this is anonymous or not. I never used it before. Maybe it won't work, who knows? But yeah, I decided to use it. If you wish. Yep.
Is it possible to get the slide before?
Oh, slide before. I have very similar at the end. So you will have your chance if you wish. So, and I have a question for all of you. Who of you is on call? Okay, only one person? Oh, okay, 2, 3, okay. Okay, who knows what is on call? Okay, more, okay, good. But I will try to explain what is on call. On call, this is a duty we have in the company when something goes off, some services goes down or some metrics goes down. We have a dedicated person with a phone, and this phone can ring any time. In the night, in the day, you're taking bathroom, it can ring and you need to reply and you need to fix the problem. This is very senior people usually, they are trained to do this, they know how to do this. We have a lot of run books to fix the problem. So yeah, this is on call. That's why I'm asking who is on call. And in Delivery Hero, we are truly global. If you look at the map, we are operating around 70 countries all around the world. So if something can go wrong, it will go wrong anytime, 24/7. And this happens. I was also on call, so it was funny times. Not anymore. And the people, these 3, who on call and who knows on call, how are you usually get paged during on call? You can speak.
Phone call, SMS, pager duty.
Yeah, I mean, a bit different how you. Okay, let me explain. We usually have 2 types of being paged. There are some local teams finding the issue or facing the issue, and then they just creating the alert, creating the incident, and we get the paged. And we have automated. So our system monitoring themselves or monitored by other system, and then we get paged when something doesn't go properly. So we have this kind of 2 types, let's say, manual and automated. And when you have automated business metrics, you can consider you are blessed. Why? Because then what you have, you receive this message, like this is message from the Slack, but you receive very similar message in your Ops Genie, in your phone, and it contains all information you need to solve the problem. So it has a query in Grafana, so you can directly go and modify this query, do some analysis, and you can work with this. Or you have dashboard, maybe some dashboard already prepared for you by the team, so you can just go and, like you have seen all dashboards in Grafana. You just open it, can show some threshold saying, okay, this is bad. You have run book, some description of steps you need to do to solve the actual problem. And you can sneeze. So if you don't know to do something, just sneeze it. So yeah, this is example of query. So just raw query. So you can modify it. You can add some aggregation, whatever you want. So you can play around with this if you wish. Maybe change threshold to understand what is going on. Or you have already prepared dashboard, as I said, which has some titles telling you and maybe some thresholds showing. So this is going something out of the normality. And then the run book. I love it. I'm responsible in the company to push people write run books. And this very well-written document where we have everything from what is this alert about, what metrics you need to check to assess the alert, what steps you need to do. And this one even has some commands you need to run in your Kubernetes to do something. I don't remember about which one, but I think this is how to drain your node. Because I also removed some sensitive information, so I can't match it back. So yeah, if you have automated alert, you have almost everything you need to solve the problem, because then this problem was faced before by other engineers and they already created some guidance how to do this. Yeah, so having automated alerts, you are blessed. This is good. But there are a lot of cases when we have, as I said, we are a global company, we have local teams, local operation teams, which are in the closer contact with dispatchers and with end delivery guys, riders. So riders may start to complain about something, then this being aggregated by this team, and then team creates the alert saying something doesn't work. And the problem of this manual escalation, because those people who is collecting information, they are not technical people, they are not aware about details of our system. And yeah, just let's see. So we receive message like this. Service impacted rider application, okay, subject rider application in this country is loading too slow and impacting delays and rider experience. What is wrong? So for sure, this is only the title of the problem. We have some description. We sometimes have some screenshots. But for us, it's most important right here is rider app. This is actually how we map manual escalations to which on-call team should be paged, because we have maybe 50 on-call teams in entire delivery hero. So to understand which team should be paged, we have some keywords, we do some regex matching, and we page the entire proper team. But it doesn't mean the local team knows which keyword to use and the correct team will be paged. But let's go. Okay, we know something wrong with rider app. So rider app received this notification and they need to do something. They need to deep dive to understand what is going on. So then we have this description, and description tells you, rider app is too slow and riders are facing difficulties in starting the shifts and making orders pick up and drop off as it's taking much time. This is increasing the overall delays of the system and impacting experience. Also, only rider app is impacted where yeah, this is original, so it may have some typos. All other apps are working fine with no issue. So again, we will pick some keywords from this text, and what it says starting shift and making orders pick up and drop off impacted. And what does it tell to you? Okay, maybe nothing. And the same I would say for me as on-call engineer. Why? Because those two systems are different systems. Shift systems and making orders pick up and drop off. Even making orders pick up and drop off, two different systems. So they're complaining something globally doesn't work. Why? Because we are using this microservice architecture, so all of these are different microservices. Responsible for shifts, responsible for pickup, for drop-off, because we're doing different stuff on every of this stage of the life cycle of delivery. So then it means this text doesn't tell us anything yet. What we can do? So we also have another section which steps to reproduce. Okay, we're reading this on open rider app, start a rider shift, it's too slow, and riders are facing difficulties in starting. Okay, accept order, mark order pickup and drop off. The app is responding slow. This is very interesting because for some reason acceptance works faster than everything else, but then it still doesn't tell us anything. So at this point of time, what our teams will think about what is wrong, it will be maybe something wrong with application itself. And yeah, what we do, we are checking metrics, and at the same time, we have communication with this local team. We're asking them about more information. As I said, we get nothing from this message, I need more information. So we're asking which platforms are affected, maybe some specific versions, or maybe they can give more details, more screenshots, provide some videos uploaded, so we can try to narrow down where is the problem. And yeah. So we're asking, and then we're starting to check in our metrics. We look into our service metrics, at least one of them, and everything looks fine. I mean, this is normal situation. We don't see any drops or spikes, so everything works as expected. And then what we do, all metrics are fine, no deviations, no spikes, no drops. And at some point, we can consider this incident is false positive because we can't find any evidence in our system something is wrong. At the same time, we may be not monitoring our system enough to make this decision, but what we can do, we can ask local team, is this still ongoing? It could be some event happened for 5 minutes. This triggered a lot of riders to contact dispatchers, and then we have this incident and this already over. But no, we ask it, they continue. No, I have this slide. Okay, whatever. This is our entire kind of route which your request goes from the mobile. Maybe let me have this. From the mobile, then internet service providers and Cloudflare. Hello, Cloudflare. Which can go, yeah, this can go wrong, you know now. I knew this before. So then we have our cloud, we have load balancer, we have our Kubernetes. So any of these things can go wrong. And so far we checked metrics only of this small part. So we need to check metrics for everything here, and this is a lot of data to validate. And at the same time, we're still trying to get more information out of our description, initial description, because yes, maybe written in very vague form, but there are some information, important one. And right now, important that only rider app is impacted. This maybe tip us that the problem really with rider app. And what we will do, usually we will check if we have any new release recently. We check, do we have any new release? No, we didn't have release. So we can cross this and in this, yeah. And we also receive reply from the local team saying it's impacting both platforms. I mean, problems in mobile application development may happen, but they can't happen in two places simultaneously. So this clearly points the problem with our backend somewhere. So from this big diagram, we already crossed two parts which seems to be fine. So we don't have problems with mobile, we don't have problems with our applications because they're behaving fine. So we need to check everything else in the world, actually. So we're checking everything else, and first we have a conch, our gateway and authorization tool. We check, and metrics seems fine, everything works fine. So problem maybe not in conch, maybe, who knows. Then what we go and check our engines, and again, yeah, metrics looks fine. There is no deviation, there is no spikes, everything looks fine. Then we also check metrics of load balancer, and yeah, it's also fine. And then we look at these two guys at the end. We have ISP and Cloudflare, and how to monitor and understand if it works fine, something you don't control at all, because it's outside of your cloud, this outside of your phone. So this is two parts which you absolutely don't have control, and absolutely you don't have any monitoring to understand. I mean, Cloudflare, you still have monitoring, but it's not monitoring you want to have. When you go to Cloudflare dashboard, you have a lot of ways to filter data, to understand what is going on in Cloudflare. Do you have a cache? Do you have some outages? Do you have DOS attack? But there is no any metric saying what is P95 or P99 of your requests. They don't count it, they don't collect this information. So Cloudflare, you don't know. Maybe something wrong with Cloudflare, and we know this happens. And yeah, what to do? ESP providers. What you can do with ESP providers, you even don't know somewhere on another side of the world. So, yeah, how to monitor something you don't have access and you absolutely don't know where it is actually physically. So what we do, this is incident handling nightmare. You know something is going on. You know a lot of people complaining it doesn't work, but all your metrics showing it's fine. I mean, this is the same what happened recently with outages of AWS, outages of Cloudflare. You can just only sit and wait when they fix it. But at least with these two, you know where is wrong. Here you don't know where is wrong and what is wrong, and you don't know where to check where this could be resolved, because local teams, they have power to close the country. And this is biggest problem which may have in the operations for us. If they close the country, we don't receive orders, we can process orders. This is no revenue, no money, we are losing money. And if we don't provide ETAs when it will be resolved, the problem, they can just close it, because like bad experience is much worse than not delivery at all. So at this case, we got a bit lucky, because for our mobile development, we use Firebase a lot. And who of you are familiar with Firebase? Okay, yeah, more people familiar with Firebase, that's good. And Firebase has this performance metric. This is good to have, but the problem, it's free. A tool from Google, which very terribly to use, let's say. You have metric only right now, and you can't find this metric after 2 hours or how it was 2 days ago. So you can't filter, you can't narrow down. So this screenshot was taken during the incident. And in 30 minutes when it's resolved, you will never see this again. So keep your screenshots. And this is amazing, because this shows what is wrong. For some endpoints, latency increased like million times. I don't know how much it was, but you see 6.5 minutes. How it's possible? We should have some timeouts in our system. So for sure, this request never reached our system. It missed somewhere before. So we have this metric, and this metric on the first stages saved us a lot, because we were going and checking, okay, yes, there is something going on, and there is something what is going on with particular internet service provider. I remember we even were able to narrow down to a specific internet service provider, and our local team was calling, we have outage. And then what we were doing, we were instructing our riders to use as a Wi-Fi from the, I don't know, cafes, restaurants, or in our dark stores, or switch to another internet service provider, because riders, they are experienced riders, let's say. They never have only one device with one provider. They have multiple devices, because it can go out of the charge. They have multiple SIM cards, so they can manage this, they can switch. So yeah, we have solution, we have some ways to monitor right now, but the problem, yeah, as I said, it's great to have it, but it's free and we don't have any power to push it to improve because it has very limited functionality. As I said, you can maybe understand what is going on right now, but in 30 minutes, it will not show you these spikes anymore because I don't know why. So, and this is how this metric from the title was born. We call it time to the backend. And this actually means how much does it take for the request when it was initialized on the mobile device to reach our backend before it will be started to process. So this is real time to the backend. The time takes for the request to reach our backend from the mobile. And yeah, so this is how it looks like from here up to here. This is our time to the backend. And how it works, absolutely simple. You know this rule. If it's dumb but works, it's not dumb. It's very simple. We have a header. For every request, we add a header. It's like X time to the backend, blah, 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 or request initiated. So we add timestamp to every request in the header. And then when backend receives this request, it calculates the difference between these two timestamps. And then we can say, okay, this took this amount of milliseconds or seconds to reach our backend. You may say like, what about these bad riders or bad devices where this out of sync? And yeah, when it's not synchronized and when riders manipulating the time. I mean, still we have maybe 200,000 active riders per day simultaneously. And if 1 or 2 or 100 or 1,000 modify time, it will not very much affect the metric itself. It won't be visible. So we have a lot of metrics to prove it. So this is how actually metric look like. So from the down to up, we have these buckets with time frames. How long does it take? It starts from the 50 milliseconds up to infinity, more than 30 seconds. We count all of this, and you can see distribution. So distribution, like a lot of requests doing this in less than 50 milliseconds, and some of them like going higher, higher, higher. And what is interesting, this is how like incident actually looks like. Where you see this discrepancy, this spike, something moved out of the normal distribution, you can clearly say this is something going on, this is incident. And based on this, we can define them alert. So you can have alert with runbook what to do. I have more clear example. This very recent one, like you can clearly see something going on, right? Amazing. We have a metric, and then when we can ask how you get paged, we move it from the manual escalation from local teams notifying us about something goes wrong to having automated business metric monitoring our system, monitoring change in this metric, and notifying on-call team this needs to be investigated and solved. And did we create a masterpiece? I would say this metric was created 2021. I would say that time it was really a masterpiece because, as I mentioned before, to validate there is an issue, and this issue related to ESP provider, we had to check a lot of metrics. And you need to understand that having this microservice architecture, it means you need to check all your services because any of them can have some problems with latency, problems with reading from database, and then it will be reflected somewhere in application. So you need to really go through a lot of metrics. And then we just squeeze it into one metric. So I would say it was a masterpiece. And yeah, this is also how, this is a question, what is the time to the backend actually? This for sure exaggeration, it's not everywhere, it's some countries because you need to understand how your infrastructure deployed and where your customers are because you may have your infrastructure in Europe, for example, in London, in Ireland, but your customer somewhere in Australia. So the ping will be very huge, and this ping is visible in this metric actually. So answering your question, the time to the backend is 2 seconds for us. And this is, you can imagine, 2 seconds, it's something feasible. When you have a device, when you click, for example, button, you will wait 2 seconds to have response. And the trick here, because this is one direction latency, so you wait 2 seconds for request to reach your service, and it processes it, blah, 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 and then it takes 2 seconds, go back. So eventually it's 4 seconds. 4 seconds, it's already like ages. It's very, very feasible thing. So, yeah, this is my favorite slides. Feel this moment, like internet is, light of speed is not infinite, and internet is very, very slow, actually. Welcome. Should I start from the beginning? Can we just use observability for this case? We had a lot of debates about this, but the problem, because we have mobile and we have backend. And for what we monitor for mobile and what we monitor for the backend is absolutely different things. I mean, from observability perspective. Because for mobile, they usually use this conception of sessions. So the client rather open the device and this starts the session, and they monitor how long does it take to load the screen, to load different frames of the screen, and this for them is a metric. And for backend, we more concentrated on the measuring requests and how does it take this individual request. So we measure absolutely different things on observability for mobile and backend. It's very complicated to find the sweet spot where we can match these things and to have some generic metric. We're actually working towards this because we define it in Delivery Hero that for backend, we will have Grafana as our main observability tool, and for all mobile web, we will have Sentry. And Sentry, kind of, as far as I know, we can export some metrics, so we can export metrics. This is not a metric. This is what we need to monitor. This is spans and traces. And he is a bit more complicated. So we're still working towards this to have observability to replace all of this. But this metric we created maybe will stay with us for years. As I said, it was created 2021, and we're in 2025. It still exists, and we still use it. So, yeah, I wanted to add something here, but I forgot. So, how to improve? It might be very fun, but using TCP protocol is already very slow. Because you have all these handshakes, you have this SSL, you have all of this which slow down. And using UDP is much faster. And this is actually, I believe, what these guys from Warcraft did. They used UDP.
It's peer-to-peer. So it's basically a WebSocket.
Oh, WebSocket, yes.
Just a regional packet optimization.
Yeah. I mean, using TCP is already, you're in the wrong direction. What we're also experimenting in Delivery Hero to use HTTP3. And in some cases, we notice it improvement in 200 milliseconds on handshake. So you can improve something, but again, remember about 4 seconds. 200 milliseconds, 200 milliseconds and 4 seconds. It improves something, but not that much. And yeah, this is the difference between HTTP2 and HTTP3, and where this win of 200 milliseconds actually happens. This experiment is still not concluded in our case, as far as I know, so we're still looking into it, and you need to understand all of this. You remember this diagram of chain of calls. All of this should support HTTP3, otherwise it won't work. So yeah, as a conclusion, before optimizing your application performance, make sure you need it. Because as I said, if you can optimize in your application few milliseconds, maybe you lose 4 seconds somewhere else where this optimization will disappear. Make sure it will bring a value. Again, I mean, you can spend years optimizing for few milliseconds, but I mean, no one will notice it. You will not win anything. And make sure you have full picture. I mean about this full picture, how your requests go from your mobile to your backend, because you should understand this and measure, actually. Optimize only when necessary for a defined value and with a complete understanding. Anything else, anything less is a gamble with complexity. Yeah, and kudos to Jonathan Amsterdam. His talk a couple of years ago on GopherCon inspired me about this, because he was talking about changes on Golang related to HTTP server handler, router actually. And he was saying like they were introducing better support for different types of passes you can provide with some regexps and matching. And he said it was huge pressure from community to keep SLAs. And he said, how you can talk about any, P99 and latency when you use JSON? So yeah, and then I recall it, okay, we have a metric which shows how you optimize your HTTP server to work 1 millisecond faster. No one will notice this 1 millisecond. Yeah, and again, if you will have any questions, you can ask me here, or you can contact me on any of these social networks, or as I said, Sessionize provides this QR code where you can provide me feedback. I don't know how it works and if it works, actually. You try, you tell me, please. And I believe that's all. Thank you.